In the furthest reaches of our solar system, beyond Neptune, lies a region filled with icy bodies and mysteries. Welcome to the Kuiper Belt. For those that dare to venture further, past the familiar confines of our solar system's more prominent celestial entities, there dwells an entity of cold silence and unyielding mystery, an expanse that extends to the outermost limits of our celestial neighborhood. This realm, which we've come to denote as the Kuiper Belt, is a vast frontier. It is filled to the brim with countless celestial bodies of intriguing varieties. Each one, distinct in form and composition, holds a unique narrative of the past, a silent testament to the unending cycle of formation and decay that governs the universe. The Kuiper Belt seems to defy the standards of our understanding. Here, the ordinary laws of planetary formation and composition give way to a new order. This order is one that is characterized by the dominance of ice and extreme cold temperatures, a testament to the far-reaching influence of the sun, though distant as it may be. The belt, named after the renowned Dutch-American astronomer Gerard Kuiper, is a treasure trove, a wealth of information that is invaluable in our quest to understand the early stages of our solar system's formation. Each element found within this vast expanse contributes a piece to the intricate puzzle of our cosmic history, offering researchers and scientists alike a glimpse into the mysteries surrounding our solar system's birth. The Kuiper Belt can be seen as a cosmic freezer of sorts. It preserves ancient relics from the time when the planets were first forming, remnants of a past long gone but not forgotten. These elements, frozen in time and space, are the clues that provide us with the invaluable insight necessary for unraveling the mysteries of our universe. Many of these celestial bodies have been observed to retain their primordial characteristics, untouched and unaltered since their formation. They are relics of the past, preserved in the cold depths of the Kuiper Belt, lying in wait for the curious gaze of future explorers. These celestial entities, scattered across the belt, range from minor planets and dwarf planets to comets, each with its own unique story. These celestial bodies are not only testament to the rich diversity of the solar system, but also provide a unique opportunity to study the various processes that have shaped our universe. As we delve deeper into the secrets of the Kuiper Belt, we equip ourselves the knowledge necessary to navigate the uncharted territories of the cosmos. Each discovery, every piece of information gleaned, is another step forward in our relentless pursuit of understanding. In this grand quest for knowledge, we prepare to journey into the unknown. We leave the comfort of the familiar behind, venturing into a world dominated by ice and cold. This is an interstellar adventure of epic proportions, a journey that pushes the boundaries of our understanding. Every celestial body we uncover, every mystery we unravel, not only enriches our understanding of the universe, but also brings us closer to answering the age-old question: how did we come to be? The Kuiper Belt, with its myriad icy bodies, poses a challenge, a puzzle waiting to be solved. Icy body holds a mystery, a secret that could unlock further understanding of our universe. As we continue on this journey, we look to the stars with wonder, curiosity, and a will to explore. Every icy body, each frozen fragment that we study, brings us one step closer to understanding the universe we inhabit. They stand as silent testament to the grandeur of the cosmos and the mysteries it holds. We're about to embark on an interstellar adventure, uncovering the mysteries of the outer solar system, one icy body at a time. Born from the remnants of the solar system's formation, the Kuiper Belt is a treasure trove of information. It's a fascinating region, located at the far reaches of our solar system, beyond the orbit of Neptune. But how did this icy frontier come into existence? The Kuiper Belt's formation is believed to go hand in hand with the birth of our solar system around 4.5 billion years ago. Picture this: a vast, swirling cloud of gas and dust, which we call a nebula. Within this nebula, the sun is born, and the remaining material starts to form a circumstellar disk around it. Gradually, these particles start to collide and stick together, forming larger and larger bodies, leading to the formation of planets. But beyond Neptune, the process was different. Due to the sun's weaker gravitational influence in this region, larger bodies couldn't form. Instead, we're left with a belt of smaller bodies, the Kuiper Belt. But what exactly is the Kuiper Belt made of? Primarily, it's composed of icy bodies, sometimes referred to as dirty snowballs. These are mixtures of water ice, methane ice, and ammonia ice, with a sprinkling of rock and metal. The extremely cold temperatures out there have preserved these objects in their original pristine condition, making them cosmic fossils of the early solar system. Within this icy frontier, we find a variety of objects including dwarf planets, asteroids, and comets. Notable among these are dwarf planets like Pluto, Eris, Haumea, and Makemake, but the Kuiper belt is also home to countless smaller bodies, some of which occasionally get deflected towards the inner solar system, becoming short-period comets visible from Earth. In essence, the Kuiper belt is a cosmic time capsule, a vast repository of the solar system's early history. Each icy body within it holds clues about the conditions and processes that prevailed during the solar system's infancy. So it's more than just a collection of icy objects. It's a valuable resource for astronomers and planetary scientists. This icy frontier is a window into the past, showcasing remnants from the birth of our solar system. By studying the Kuiper belt, we're not only exploring the farthest reaches of our celestial neighborhood, but also journeying back in time, uncovering the secrets of our cosmic origins. The Kuiper belt, a realm far beyond Neptune, is a vast expanse waiting to be explored. This outermost region of our solar system is like a cosmic treasure chest, brimming with remnants from the birth of our planetary neighborhood. So, where exactly is the Kuiper belt? Picture the solar system. Now, journey past the 8 planets we're familiar with, past Neptune, and into the realm of the unknown. The Kuiper belt begins at about 30 astronomical units away from the Sun. 1 astronomical unit, or AU, is the average distance from the Earth to the Sun, roughly 93 million miles. So we're talking about a distance nearly 30 times that between Earth and the Sun. It's a region so expansive that light from the Sun takes over 4 hours to reach it. Now imagine a donut-shaped ring extending from this point. That's the Kuiper belt, stretching outwards to about 50 astronomical units from the Sun. It's a region that's 20 times as wide as the entire distance from the Sun to Neptune. That's a lot of space, isn't it? But it's not just about the vastness of this region. The Kuiper belt is also densely populated with celestial bodies. It's estimated to contain over 1 trillion icy bodies and hundreds of thousands of planetesimals, the building blocks of planets. Among these are some of the most intriguing dwarf planets in our solar system, like Pluto, Eris, Haumea, and Makemake. The sheer size and location of the Kuiper belt make it a region of immense interest. Its icy inhabitants are frozen time capsules, preserving the early history of our solar system. Studying these objects gives us clues about the early solar system and how it evolved over billions of years. In this extensive region, the Kuiper belt holds many secrets that are yet to be discovered. As we continue to explore this distant realm, who knows what mysteries we will unravel about our cosmic neighborhood and beyond. Among the icy bodies of the Kuiper belt, dwarf planets and other celestial bodies make their home. This region of our solar system, extending beyond Neptune, is a veritable treasure trove of dwarf planets and other fascinating celestial bodies. One of the most famous residents of the Kuiper belt is undoubtedly Pluto. Once considered the 9th planet of our solar system, Pluto was reclassified as a dwarf planet in 2006. But don't let its demotion fool you. With its intriguing heart-shaped glacier and a diverse landscape of mountains, valleys, and plains, Pluto remains a celestial body of great interest. Next, we have Eris, the most massive dwarf planet in the Kuiper belt. Named after the Greek goddess of strife and discord, Eris sparked a fierce debate about what constitutes a planet, ultimately leading to Pluto's reclassification. Haumea, another dwarf planet, has a unique elongated shape, unlike any other known celestial body. It has 2 moons and a ring system, making it one of the most intriguing bodies in the Kuiper belt. Makemake, the second brightest object in the Kuiper belt after Pluto, is another dwarf planet. It is named after the creation deity of the Rapa Nui people of Easter Island. Aside from these dwarf planets, the Kuiper belt also hosts a myriad of other celestial bodies. These include icy bodies known as Plutinos, named after Pluto, and Cubawanos, named after the first of their kind to be discovered, 15760, 1992 QB1. Each of these celestial bodies, with their unique characteristics and compositions, provides us with invaluable insights into the outer solar system. They help us understand the early stages of our solar system's formation and how it has evolved over billions of years. So, while dwarf planets may not enjoy the same status as our 8 officially recognized planets, they hold a special place in the celestial hierarchy. They remind us that even in the cold, distant reaches of our solar system, there is much to discover and explore. These dwarf planets and other bodies provide invaluable insights into the outer solar system. The Kuiper belt, once a mere speck on the map of our solar system, has been brought closer by the quest for knowledge. In the grand theater of space exploration, the Kuiper Belt has played a pivotal role. The first mission to really shine a spotlight on the Kuiper Belt was NASA's Pioneer 10. Launched in the early 70s, it gave us our first distant look at this mysterious region. Although it didn't reach the Kuiper Belt, it paved the way for future missions. Next came the Voyager missions, launched in the late 70s. Their primary mission was to explore the outer planets, but Voyager 1 and 2 also provided valuable data about the outer edges of the solar system. The Voyager missions gave us a glimpse of what could be out there, beyond the planets we knew. The most significant mission to the Kuiper Belt, however, was New Horizons. This NASA spacecraft, launched in 2006, made history in 2015 when it performed a flyby of Pluto, the most famous resident of the Kuiper Belt. For the first time, we were able to see Pluto and its moons up close, revealing a world of mountains, glaciers, and a thin but present atmosphere. New Horizons didn't stop there, though. It continued on to perform a flyby of Arrokoth, a Kuiper Belt object, in 2019, providing us with even more insights into these distant, icy worlds. Currently, there are plans for future missions like the proposed interstellar probe, which would travel even further into the Kuiper Belt and beyond, into interstellar space. These missions have not only expanded our knowledge of the Kuiper Belt, but have also challenged our understanding of the solar system and its formation. They've shown us that the Kuiper Belt is not just a frozen wasteland, but a vibrant region filled with diverse bodies and complex processes. With every mission, we inch closer to unraveling the mysteries of the Kuiper Belt. While both house celestial bodies, the Kuiper Belt and the asteroid belt, are two distinct regions of our solar system. The asteroid belt, located between the orbits of Mars and Jupiter, is akin to a cosmic quarry, teeming with rocky remnants from the early solar system. Its occupants, primarily composed of rock and metal, are often considered the leftovers that never coalesced into a planet. Contrastingly, the Kuiper Belt, situated beyond Neptune's orbit, is like a frozen museum, preserving icy bodies and dwarf planets from the solar system's infancy. Its members, predominantly made up of ice, think water, methane, and ammonia, encapsulate the pristine building blocks of the solar system's outer planets. Both belts serve as a window to our cosmic past, yet they differ significantly in their composition, location, and the types of objects they host. Though similar in some respects, the Kuiper Belt and the asteroid belt each hold their own unique tales. The exploration of the Kuiper Belt is far from over, with upcoming missions promising to uncover more of its secrets. With every passing year, the mysteries of this distant region of our solar system beckon scientists and researchers to venture further and delve deeper into its icy depths. Several future missions are already on the drawing board, each with its own set of objectives and queries to answer. The European Space Agency, for instance, has its eyes set on the Comet Interceptor mission. This ambitious project aims to study a pristine comet or interstellar object that is making its first trip into the inner solar system. NASA, on the other hand, is planning the Interstellar Mapping and Acceleration Probe, or IMAP mission. This mission will help scientists better understand the boundary of the heliosphere, a protective bubble that shields our solar system, including the Kuiper Belt, from interstellar radiation. In the not-too-distant future, we may even see missions specifically designed to target and study individual Kuiper Belt objects, or KBOs. These missions could provide unprecedented insights into the composition, structure, and history of these distant bodies. Each of these missions holds the potential to revolutionize our understanding of the Kuiper Belt. They promise to shed light on the early formation of our solar system and perhaps even answer the age-old question, are we alone in the universe? As we continue to explore the Kuiper Belt, who knows what new discoveries await us? The Kuiper Belt, a frontier of icy bodies and dwarf planets, has much to reveal about our solar system. This distant region, brimming with diverse celestial objects, helps us understand the formation and evolution of our solar system. From the well-known Pluto to the myriad of lesser-known trans-Neptunian objects, each discovery adds a new puzzle piece to the grand cosmic picture. As we continue to explore and understand the Kuiper Belt, we delve deeper into the mysteries of our own cosmic backyard.